So in this video, we're going to talk about a few theorems of angles, a little review, and a couple proofs as well. So just a reminder, if you have two parallel lines like these two, any line that cuts through it is called a transversal, and it creates lots of congruent angles. 1, 3, 5, and 7 are all congruent, and then 2, 4, 6, and 8 are all congruent. If I had another transversal, it would do the same thing. These 4 would be congruent, and then the other 4 would be congruent. Just to remind you on that vocab, the ones that are in like kind of the same position, like top right and top right, those are called corresponding angles. They are congruent. If they're opposite each other on the inside, they're called alternate interior angles. Those are congruent, and these are congruent. If they're opposite each other on the outside, they're called alternate exterior angles. They're also congruent. And then we've got vertical angles, which are just across from each other. Those are also congruent. So like what kind of angles are these, X and Y? Those are corresponding angles because they're kind of in the same position. They correspond to each other. These two, also corresponding angles. These two are alternate interior angles. These are vertical angles. Those are some more alternate interior angles. And then I want to remind you of these two words as well. So complementary means they form a 90-degree angle. Complementary angles add up to 90. Like 38 and 52 are complementary angles. If they ever form a straight line, they're called supplementary angles. These add up to 180 because 180 is like half of a full circle, basically. So 180 and then 360. See how like 128 plus 52 would add up to 180, and so those are what we call supplementary. Also, if you ever hear adjacent angles, that just means they're right next to each other. So like technically these are adjacent, they're next to each other. So are these, they're adjacent. All right, so we're going to use this to do a proof that vertical angles are congruent. And it's actually a fairly straightforward proof. Think about if I have two lines that intersect. Oh, sorry, the board trips out over there. If I have two lines that intersect, think about these two angles right here. These two angles are supplementary. They add up to 180. These two angles are also supplementary. They add up to 180. And so basically, if this is 180 and this is 180 and they both shared that middle angle, then these two have to be the same. That's pretty much the proof. Let's actually just write that out. So, for this proof, let's draw two lines. This is kind of what we're given. I'm going to label this 1, angle 2, and angle 3. Okay. So, again, I know that 1 plus 2 equals 180 because they're supplementary. If you want a reason for that, it's because they're supplementary. I know that 2 plus 3 equals 180 as well because they're also supplementary. Let's just do a little algebra here. If I were to subtract 2 from both sides, I would get that angle 1 is equal to whatever 180 is minus angle 2. Like, take 180, subtract angle 2, and you get angle 1. Same thing here. I could also subtract angle 2, and so angle 3 equals 180 minus 2. So 180 minus whatever angle 2 was, and that gives you angle 3. See how these are the same? Since 1 and 3 both equal the same thing, angle 1 equals angle 3. And that's the end of the proof. QED, draw your square, you're done. Drop the mic. I just proved that these two vertical angles are congruent, and that works for any angle because I just used a generic 1 and 3. We're going to do one more proof, a proof that alternate interior angles are congruent. So, now that I've proved vertical angles are congruent, I can use that in my next proof. So, I'm going to go ahead and draw out two parallel lines. That's what I'm going to start with. We'll call it lines L and M. And I've got a transversal that I'm going to call T for transversal. I'm trying to prove, let's number these. 1, 2, 3, 4, 5, 6, 7, 8. Just to give them names, kind of number them. I'm trying to prove basically the angle 3 and 6 are congruent, alternate interior angles there. I want to write this one out as two columns, so here's like my statement and my reason. First of all, I've got that L is parallel to M with transversal T. That was just given. Next, I know that angle 3 and 2 are congruent. How do I know that? Well, I know that because they're vertical angles. And vertical angles are congruent. I also know that 2 is congruent to 6. How do I know that? Well, those are corresponding angles. So 2 is congruent to 6. That's because they're corresponding angles, and corresponding angles are congruent. And that's pretty much it. If 3 is congruent to 2, and 2 is congruent to 6, then 3 is congruent to 6. And there you go. This has a name. We've mentioned it before. It's called the transitive property. Basically, if you link things up kind of like a train, like 3 goes with 2, 2 goes with 6, so I could just skip the middleman and say 3 is congruent to 6. That's called the transitive property. It looks like this, basically. If A equals B and B equals C, then we could just jump straight from A to C. That's called the transitive property. And that's it. That's my proof. I proved that 3 is congruent to 6. Those are alternate interior angles.